Okay, get ready for this. Listen to this. This is unbelievable. There's no electron, there's no this, there's no that. Here we go. Listen to what he has to say. This is Mikhail Kaku, or whatever his name is, something like that. Mikhail Kaku. All right, here he goes.
There's no electron. There's no proton. There's no neutron. Matter as we know it is not there. Therefore, it cannot describe the universe. String theory is the only theory that combines Einstein's theory of gravity with a theory of particles. The main criticism of string theory, which has to be taken seriously, is, well, where's the beat?
Where's the beat?
Where are these particles that are predicted by string theory? String theory predicts the electron, it predicts the proton, it predicts the world that we see around us. But, and it's a huge but, it also predicts other particles. Particles heavier than what you see around us. So where are those particles predicted by string theory? One idea is that these particles make up dark matter. There's no...
Well, let's see about that, Mikhail. All right, he's talking about string theory solves all these problems. No, it doesn't. It says in physics, string theory is a theoretical framework in which the point-like particles, those are the little white jobbers I'm going to show you, of particle physics are replaced by one-dimensional object called strings. String theory describes how these strings propagate through space and interact with each other in a manner of saying yes, but there's nothing to do with a string. It's a particle that's spinning, and it has a field. On distance scales larger than a string scale, a string looks just like an ordinary particle with its mass, charge, and other properties determined by the vibrational state of the string. Well, I forget about all that, because I can show you the actual particle. These are the particles that Fermilab found. We found the same particles, only they started with huge balls of mass like these and smashed particles like these, and all they saw was debris. But they did see these are the two smallest particles that exist, and I agree with that 100%, only they are from light. We started down here, so we didn't have to look through all kind of debris. We could see the light right here, and then we could actually separate the black from the white, and we did that right here. The black can't get through the Venturi, only the white in the showers. So we did, this is from CERN and Fermilab, muon neutrinos, electron neutrinos. That's the black and the white. The electron goes through as a shower, and the black balls just go on their own. They call them sterile muons. We did that because of the Venturi accelerating the light. All of this stuff is not accepted and not allowed to be spoken about because it violates all their rules and laws. Those rules and laws are just wrong. That's why they never got anywhere for the last 100 years. Now, Mikhail Kaku is a science communicator. He should talk to me because this is the correct model, is dipole electron flood theory. I just showed you what light is made of, is two dipoles, the black and the white and the black and the white, just like bar magnets. Only I never realized you could separate the black and the white. I never realized. But in the subatomic realm, you can do that. When you get bigger than a bar magnet and you break it in half, you get two bar magnets. You break them in half again, you get another two and another two, and they just keep, you can't ever get out from being a bar magnet. But when you're down in this realm, they do separate. And the black of these bar magnets, and that's all everything is made out of, is these two particles. And they come in as a bar magnet, the black and the white attached together. That's all there is. And everything is constructed of those two. And those two I call atomic vapor. There is a glue that glues those two together like unbelievable. That's what electricity is. The white wanting to get back to the black. The black has all the mass and no burn. It's cold. So this is absolute zero. There's no energy there whatsoever when it's stationary. It'll knock a house over if you shoot a whole batch of these at a house. This won't knock a house over, but it will burn a house. I showed this with atomic bomb blast. The bomb goes off, the house just vaporizes like this. And then a second later, the black comes and the house goes flying. This is dipole electron flood theory. So what is the nucleus of an atom made of? Well, it's made of those dipole particles, the black and whites. Only when you put them together in a nucleus, in an atom, all the black goes to the center. That's why you never saw it. All you ever see is the glowy ones. You shine a light on it, it shines it back at you. It bounces back. Well, guess what's in the middle of this? The dark matter. All right? The dark matter. Now, when you get down in the range where we are in using light, we're down in this range here. And again, we just pulled one of these dark and white particles off, just one of them, out of that whole batch. That's what light is. Light is down in that range. That's why it just doesn't, it's just all over the place. Light is everywhere. You just don't know it. Because it's down in the range that's just so small that it just is nothing. But it is something, and it is a particle, and two of them together, two of these dipoles together, that is light. That's light right there. All right, because each one of those has a plus and a minus, a black and a white. And I showed you that is light. That's what light is right there. Now, not only is it red, it's green and it's blue. It's the same structure, only the green and the blue are much faster than the red. But they have the exact same structure, and they all accelerate the same way with the Venturi, and they have the black and the white, with the glowy edge around the black. And if it was green, it would have a glowy green edge, so I will show you that. All right, you saw the red photon, there's the green photon. And if you looked at it, you got the white ones. This is the gluon, that's the gluon, back to back, just like two-bar magnets. Now, the reason this doesn't fall apart and it stays as a photon is because it has a huge field surrounding it, very large. And when that field bounces against any other field, and everything has a field, everything there is has a field around it. Everything there is has a field surrounding it because there's electrons on the outside of it. That's why they bounce back at you as light. So this has a field surrounding it, and everything else does. So when its field bounces against another field, it bounces back as light. Now, if there was only one of these instead of two, it would want to glue itself into whatever it was bouncing into as heat, if the thing wanted it. In other words, if it wanted more electrons, it would say, okay, come on in here. We can take you because we're cold. All right. If it was already warm, it'd say, get out, bounce, go away. That's the transfer of heat and cold is one of these. All right. Lightning and electricity and static is just the white. Just the white. Has nothing to do with the black. The black is not involved in static electricity, right to ground, because ground is the black. The white wants to get to the ground. So it goes right to ground. Lightning, right to ground. Electricity, right to ground. It will go right through your body and explode you to get to ground. That's how desperately the white wants to get to the black. And the earth is solid. It's solid. It's not like this. This is energy. The earth is made primarily of dark matter because light is half dark matter. Everything there is half dark matter, and the half dark matter has all the weight. And that I can prove with the atomic bomb blast. And here's what they show as the tiniest particles there are, as a Dirac neutrino. I agree with that. They say this is the matter, and that's the antimatter. It's just the opposite. That has all the mass and the weight, and that has all the energy. So this is the energy part, call it whatever you want. And this is what I would call the matter, the heavy-duty part. All right, now I can show, and here's the green coming across, just like the red does. It just goes flying out, and it's a neutrino until it turns into a photon just before it hits the Venturi. All right, there's the red electrons coming, photons, coming in, and they have a dipole nature to them. You see the two blacks and the white I haven't figured out the flavors yet, but these are what they call the flavors. And they come in starting to look flat like this, like an Oreo cookie. I don't know why. Black on the top, black on the bottom, and white in the middle. And then they flip sideways. You see how all up in here they go sideways? Now they start to have the separation of the white, black, white, black. See, white, black, white, black, white, black, white. In the exact dead line that hits the Venturi, which is exactly there, they actually turn into photons. And the reason they're photons here, and the only ones that are photons fully here, are because they think they hit a wall. That's because they're being pushed back from here. So they're coming here at, let's say, 100 miles an hour. And this comes back at 50 miles an hour. And 150 miles an hour is where they turn into photons. So this is they turn into photons. They think they hit a wall right here. Just think of it that way. This wave of magnetic influence backwards to this magnetic influence coming forwards, when you combine the two of them, this thing thinks it hit a wall. And it does out here, but here it really is it's just a fabulous photon. And the green does this, they all do the same thing. So light is light. But light can accelerate, light can slow down. There's no question you can accelerate. That started out just like a regular wave, and you could just barely see it, and then all of a sudden, because of the Venturi. And when that happened, all of these waves that you could never see, because they're not going fast like this one. This one's accelerating forward. These were in the air, but you just don't see them. They're all over the place, you don't see them. But this one here created so much energy backwards that they just lit up like a neon sign. Look at them. They're all the same as this. You see the curve? They're all the same particles. So they're going through the air. You just never know they're going to be there until this one accelerated so fast and then exploded. And I'm telling you right now, and you can laugh if you want, that, my friends, is a subatomic nuclear explosion, which created fission and fusion. Exactly, if it was on the atomic scale, it's just be bigger. This is subatomic. We're below what an atom would be. An atom would be up in this area. You explode these and you have chunks like this. These will kill you if they hit you at a bazillion miles an hour. And if there's enough of them hit you, it'll just tear your DNA apart and all kinds of problems. This is light. It comes apart and comes back together within attoseconds. That's fast. All right, so what it does is it accelerates. It actually pulls the particle, which is in here, the little tiny particle that I showed you before, the black and white, up and down, two of them, and bzzz, and it takes off. It pulls itself right out of the magnetic wave, just like a rocket ship, like a jet fighter going through the speed of sound. Bam! Now it's just on steroids. And here it explodes, and because of the back push, and the subatomic nuclear explosion, everything here lights up just like a Christmas tree. You'd never even know these were here. There would be no way in anybody's world that they would know those particles are there. They just wouldn't exist. They didn't exist. They are there. You just don't know it. And you wouldn't even know this one was here either, except it's being pulled forward. That's why it's not so bright. These are so bright is because they're being pushed back at with literally an atomic, subatomic bomb. Subatomic. It's from light. These are particles of light. They are the smallest particles that exist. That's a laser. That's all it is, my friends. I don't want to bang your head with this too many times, but people just, it's too much for them to comprehend that that's possible. And this was with very, very little input. It didn't cost much to do, let's put it that way. It was tricky and it took years to do this, to get it right. But it's not expensive. And it could be, that white right there is what you want to put in your battery to drive your car. Can we get enough in a little shoebox to carry around? I think so. Because we separated that white for nothing. All we had to do was shoot the cheap laser through the Venturi, and if we could put a harvester right there to harvest that light, we're good to go. Listen to what he has to say. He's talking about string theory. There's no electron.
There's no electron. There's no proton. There's no neutron. Matter as we know it is not there. Therefore, it cannot describe the universe. String theory is the only theory that combines Einstein's theory of gravity with a theory of particles.
First of all, Einstein totally wrong, 100% wrong about virtually everything he said. Speed of light is totally variable. Light is a particle. It has a wave around it because it's got a big field surrounding it. Forget about it. String theory is not correct, but it's not completely totally wrong. Now he's saying this is the only thing that works. Now listen to what else he has to say. All right, so he's saying it's the only thing that combines everything. Combine nothing. Start from scratch because they don't know what the standard model is just wrong. So forget about that. All right, what I show, I think Mikhail Kaku should talk to me. He's saying string theory and particles fulfills the requirements, only there is nothing, nobody can show it. Listen.
The main criticism of string theory, which has to be taken seriously, is, well, where's the beef?
Where's the beef?
Where are these particles that are predicted by string theory?
All right, string theory, I'm not saying it's correct or it's wrong, but I can show you the particles that make up the proton, which I have over and over and over, and in experiments, not just theoretical. I'll show you the beef. All right, if I understand string theory correctly, and I'm not sure if I do, but they claim that the nucleus holds on to these little tiny particles with strings, basically. Some strings are longer than others, and so forth. Well, to a degree, that's correct. If you consider the strings to be magnetic energy, all right, and I will show you there will be different strengths of these magnetic fields, which you could call them different longer strings. And there is a core, and these are the particles. Now, when you get below the nucleus of an atom, you're into tinier particles, which in this case is photons. You can break these photons down, as we did, into their constituent particles, which is the muon and the electron neutrino. And here's exactly what we did. Putting it through the Venturi, the black stayed behind, the white went through and recombined with the black. So here's the light accelerating, the black stays behind, which is the muon neutrino. So we have a sterile muon. And here we have electron showers coming through the white showers. It recombines here. That says that's fission, that's fusion, and the time of entanglement between here and here is a certain time and a certain distance. But that relates only to red. Green is going to be way out here. It's going to re-engage way out here. It'll separate here, yes, but it'll come back way out here much further because it's much more powerful. So entanglement is related to the speed of the spin, which is the color. The slow spin way out here, it's spinning, but it's slow, and it looks like a wave if you look at it from the side. I agree, but it's slow, and it recombines pretty quick. Now the green is going rocket ship fast, but it's closer, it's spinning faster. That means it's more push. The distance between the waves, or the distance between the spins, basically, is how much push there is. That's energy, that's voltage. The wider the push, the fields are further separated. This is very, very simple if you understand dipole flood theory. The closer they are, the fields are very close to each other and it's pushing like hell. And when you get down to blue, they're just right on top of each other, beep, and it's gone. And it's powerful and it's energetic. That's why you create more and more and more energy. high energy and high frequency goes that way. Shorter wavelengths, shorter. Longer wavelengths, low energy, low frequency, all the way down to sound, vibration. That's all it is. Tesla, with his vibration statement about, energy, I forget what he said, but he relates everything to vibration, and that's true. It's field against field. It's push to shove, push to shove. I hope that made sense. Okay, I'm just going to let him finish up, and then we're done. He's saying string theory predicts everything. Basically, and if it's what I'm thinking it is, it's holding on to those particles, basically like I show right here. This, to me, would be the first length of the string is to the blue, and that's tight. That is held tight. If you pull that away, it's gone. It takes off and it'll never come back because it takes so much energy to pull it away. The green is that long. All right, that's the length of the string. The red string is way out here. The green will pull and usually go and never come back. The red will pull and bounce around out here because it's not held all that tight. It just sort of flexes in and out because it's still being held, but it's not enough push away that it takes off and doesn't come back. And that also, you see that in Fermilab's portrayal of what happens when they crash things. They see all the blue gone, white gone, green gone, red just sort of hangs around. Okay, my friends, so I'm going to tell you, forget about school as far as any of the stuff they're teaching you now. It's just not correct. Literally nothing. I mean, almost nothing whatsoever is correct. Almost nothing. Geology is totally ridiculous. Everything's made from mud fossils, and that changes everything. This means change, a triangle. Changes chemistry because now I understand dipole electron flood theory, biology, physics. You just see physics is totally wrong. History, mythology, religion, anthropology, archaeology, human development, evolution. There was giants, there was dragons. The myths seem to be quite true to me. Physics, the light, is made nothing but half and half of dark and white matter. And now that solves the dark matter, and it solves gravity. Gravity is nothing more than the dark pulling the white to it. And the white has no mass whatsoever. You fill your car up with electricity, which is the battery juice. It gains no energy, no weight whatsoever, none, zero. There's no weight to that particle, none, zero. That has all the weight. And the two of them together make up the light. I just showed you what a photon looks like. Periodic table's all wrong, it's got to be changed. Enzymes and the complexity of click chemistry and how the enzymes work to make life work and how proteins and catalysts work in the body and bacteria, all of that stuff is wrong, and it goes on and on and on and on and on from there. It just never ends. And the space is not a vacuum. And here's again, Don Lincoln Fermilab. Empty space isn't empty. It's full of subatomic particles that wink on and off. And it says it has a measurable impact on our universe. Yes, it slows light down. Why can't they accept the things that they can? You have to be able to understand this. These are people that we've given billions and billions for trillions of dollars to. This is 10 years ago. And I showed all my stuff to Don Lincoln. I showed him exactly the same particles that he was trying. Right here. These are the particles. They do exactly what he says, and we found them in our light experiments right here. There they are. There's his particles. There's ours. No difference whatsoever. And we can focus ours and make Higgs fields and do all kinds of stuff. And we can see those particles manifest and crash into the Ventura and explode. And we can see them in green and red at the same time. And you see how far out the green goes? The red just gets pushed out of the way. It's cheap. It's got no real power to speak of. The green is very powerful. And reconcusses way out here. That's why I say it's the spin rate. But that's the green particle. Green is a little harder to photograph than the red. Although Rod got the green fabulously. Anyway, I showed you so much stuff. I'm done for today. And I'm sorry I've taken up so much of your time. But do not waste your money on college. It's just a waste of your money if you're taking chemistry or this or that. This is wrong about everything. I mean, chemistry, I work below the atom, okay? So chemistry works above the atom, basically. I'm in the subatomic range. That's where I primarily, and isotopes, and how particles form. And it's called nucleosynthesis. And what does nucleosynthesis mean? Nucleuses, which means the core of an atom. Synthesis means rebuild it, change it, synthesize it, make it into something else. And that's what happens when you put enzymes, which come from bacteria, and they're extremely elegant chemistry sets. They break down molecules, and then they reform them into new stuff. It's almost instantaneously. They run millions of times faster in the chemical complexes than they would if they were left to do it on their own. It would eventually happen, but it would take years. In their quarter of a second, it's done, and then because it's click chemistry, that particle isn't used up, that enzyme. It goes to another one, goes click, 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 and it changes everybody. As soon as it hits it, done. Click, done, click, 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 click. It's a magnetic impulse, basically, is what enzymes do. They're like magnetic impulses. Bam, 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 bam. They don't get used up. They don't get consumed. And I guess when they're done and there's just no more need for them, they just dissolve. But they come from ribosomes. Ribosomes come from ribosomes create the enzymes, but the ribosomes come from bacteria. So the bacteria is the source of all, basically, as far as I'm concerned, the chemistry in your body. You don't have the enzymes, the bacteria, the chemistry will not happen. It just will not happen. And this chemistry has to be there in this layer that I showed you, this specific layer right there, to keep the invasion at bay, keep them out. If it gets poked through there, which it will eventually, you get a cut, which I just got a whole batch of them in my face. It'll go in here and it'll fester a little bit because your fluids will come and attack the damn thing. And you got so much of this fluid, you should never, ever, ever be attacked beyond repair because you got tons of fluid. However, you don't have the right chemistry in that fluid. I don't care what happens. You could have tons of fluid and we're not going to help you. This thing's going to come through and launch in there and just live inside of you and grow a tumor or whatever. They become obstructive. They do all kinds of things. They create all kinds of after effects, poop and all kinds of things in there. They're living inside of you and something's got to clean up after it, and maybe you don't have the stuff to clean it up. But somehow it got through that membrane. That's my point. Now, again, I'm sorry it took so long, but have a nice day. I love you.